can you hear me, Mr. Lewis?
Yes, we can.
Okay, I'm really sorry I can't find my file. So, but I think I'll go over with the presentation and see how we do. So, like I said, my name is Okon. So, when you talk about big data, what comes to your mind? So, let's break it down. So, what is data? So, data is simply facts and statistics collected together for reference or analysis. So, when you say facts and statistics, it means one, it should be true. Second of all, it should be collected together. Third of all, it's used for reference and analysis. That's what you talk about when you talk about data. So, everything you call data must satisfy these terms. So sometimes people tell you, even if it's not fact, it's still data collected, but I believe that must be fact. So when I like someone's picture on Facebook, that's data, basically. It's fact because I like the picture. So when Facebook has to count and to tell you 62 likes, so that's statistics. So when I want to do a machine learning, I want to do the machine learning algorithm, I collect this information, maybe, and I could actually tell, okay, this is what is happening on this timeline or this page. Now, first of all, I said it's facts, statistics collected for reference or analysis. Now, the term big data now describe a complex data set, so complex that it becomes very difficult to process using the normal RDBMS systems, or basically what you call the traditional data processing application. So what it means is, first of all, everybody's laptop, you see it's 4 gig RAM, basically, that's my laptop, 4 gig RAM. So imagine I am trying to compress information bigger than my computer, bigger than the traditional database system. I wouldn't have enough space to do that. So that's one problem. But as you go further, I'm going to highlight the problems and how big data came into play. Now, the second thing we'll be looking at here is, what do we consider? How do we consider data to be big? When somebody says data is big, what do we consider? So in data science, we see the 5V. That's what we use. We see the 5V. So the first thing we consider is the volume of the data, the variety of the data. So when I say volume, you understand what I mean. Volume simply means size, big size of the data. So basically in 2020, it was predicted that the accumulated digital universe of data will grow from 4.4 zettabytes, which is about 4.4 trillion gigabytes, to 44 zettabytes. That means we're expected to have worldwide 44 zettabytes of that. Can you hear me, Mr. Lewis?
Yes, we can.
Can you hear me?
Yes, we can.
Yeah, so we're looking at gigabyte of data as of 2020. So that imagine I am to process. Can you hear me?
It's the network. I think it's breaking, so it's not very clear. Hello, Mr. Divine.
Yeah, okay. I think it will be clear now. But can you hear me?
Yes, I can.
Can you hear me?
Yes, sure.
Yeah, I can hear you. Can you hear me?
Yes, we can.
So when we consider data to be big, yeah, so we're talking about first volume, yes, volume. So we're talking about variety. So variety simply means different kind of data being generated from different sources. So when I say variety, it really means web, photo, audio, all these are data. So it might not be structured. When we say structured data, we're looking at tables, semicolons. That means when we're looking at structured data, we're looking at data in tables. When we say data is semi-structured, we're looking at JSON and XML, CSV, and email. And when I say data is structured, I'm looking at something we call a log, audio, video, image. Now, for something to be a big data, it must correspond with all this stuff. It mustn't be a structured data. It might be a semi-structured data. It might be an unstructured data. So the next thing we're going to look at to consider data to be big, we're looking at velocity. And what do you call velocity? It really means that how soon is data being generated? So we know already that data is being generated at an alarming rate, but we're looking at when we say velocity, the rate at which data is being generated. And basically how we say that as data scientists or machine learning engineers, we use the word real time to tell you, okay, data is being generated in real time. So basically, if you are doing a sentiment analysis on machine learning and you're trying to understand the behavior of a particular product. So basically, every click, every like, every comment gives you a different time series graph, basically. So that's because data is being generated at real time. So the next thing we're going to consider, so like a friend of mine will tell me, he said, for every second, we're generating 100,000 tweets. That's 100,000 plus tweets. For every second, we are generating almost 600,000 status updates. Now, for every second, we're having 11 million instant messages. Now, for every second, we're having 217 new mobile users. Now, for every second, too, we're having about 700 million Google searches. And for emails, you're having about 160 plus emails for every second. That's alarming. That's a huge. So if I want to start analyzing such amount of data, that's impossible with the traditional way of data analysis. So that's really possible. Now, the third thing we're going to be looking at when we say something is considered to be big data is value. Now value simply means what mechanism am I using to bring out the correct meaning out of the data? And that includes my mining techniques, that includes my performance analytics method. So what technique are you using to do that? So that's value. So the last thing we'll be looking at is what we call veracity. Veracity. And what does veracity mean? So it means uncertainty and inconsistency in data. So you can't tell me you're generating 5 million data every second and you tell me all those data is consistent. That's a big lie. So basically, we must have some portions that are unfilled. We must have some data sets that are not defined. So veracity simply defines the quality of a particular data. So that's basically what we consider. Now, I mentioned the following. I talked about volume, variety, velocity. I talked about value and veracity. So those are the five, we call it the 5 V's when it comes to consideration of big data. Now, the next thing I'm going to look at is, okay, what about big data as an opportunity? So when you say is big data an opportunity, yes, data itself is an opportunity, man. Come on, the next generation of product, automated cars, healthcare, financial products. In fact, in terms of any form of competition, every industry is looking forward to actually get insight from data. I usually tell my friends, I was reading a post from one of my professors I was following. He said each time they go to companies to teach about economics, he's a professor of economics, especially hedge funding companies. What they tell them is bullshit the economics and teach data science, because they believe that who tells the truth better than previous data. So if I collect data for the next 10 years, it's possible for me to predict what will happen the next 1 year. It's simpler to predict that way because data gives me more insight. Now, when you talk about data as an opportunity, you're looking at faster and better decision making because it provides you ways to analyze this information quickly. Now, if I can analyze information quickly with a certain amount of data I have, basically I can actually make better decisions. And that's the importance of data. So when I say faster and better decision making, it cuts across all industry, healthcare, engineering, solid mineral mining, every industry, provided we have data, we can actually make better decisions. So I'm going to talk about big data as a career. I know we have lots of newbies who wants to go into data science, and it's really important. So according to a report I read from the International Community of Human Resource Professionals, it simply said analytics, no matter how advanced they are, does not remove the need for human insight. So no matter how advanced you come up with analytics, it doesn't remove the need for human insight. It simply means no matter how your computer does the magic, you still need human being to come and tell you, okay, this is what this thing means. Because we need to place it down with real world scenarios. Now, there's a compelling need for skilled people with the ability to understand data. So from business point of view, you know what that means. So every business person, every business organization is thinking, I think Nigeria will definitely evolve to that stage, thinking of hiring someone who understands the opportunities in data how to navigate data, how to play with data, how to make sense of data. Now, this is not me saying this. This is from an international community of human resource professionals. So, as a career, what are you looking for? You're looking at, because of the soaring demand of analytics professional, I think every newbie here should think about fostering their career around big data. Now, there's a good job opportunity for data scientists, big data analysts, machine learning engineers, but the skill gap, it's really small. So it really means any effort you're putting in yourself today will definitely pay at some point in the future. So just keep doing what you're doing. Now, it has numerous job titles when it comes to data as a career. So you can become a big data analyst architect, you can become a data engineer, you can become a big data solution architect, you can become a big data analyst. In fact, they can even call you big data associate. They can also call you business intelligence and metric consultant. They can even call you metric analyst specialist. All points to one thing: you are a big data scientist, a big data engineer. So no matter what they call you, so and that's really beautiful. Yeah, but there are problems with big data. Now, when you say big data, what are the problems? So we've mentioned that one of the problems is big, complex. So, but that's not it. Now, it's actually a problem, but we're smart people, so let's put it the way it should be. So the first thing first, that one of the problems with big data is the fact that we don't have storage spaces for holding the exponential growing rate of huge data sets, and that's really a problem. Now data is generated in fact, they say data generated in the past 5 years is more than the data generated in total history. That's really crazy. Someone tells you that you should sit down and think, what are we doing to generate data? So that's really scary. Someone tells you in the last 5 years, the data we have generated is greater than all the data we've generated in history. That should tell you a lot. Now, like I said, the total digit of data will grow from 100 zettabytes. And I told you what a zettabyte is. A zettabyte is about, I think about how many gigabytes? It's about 1 zettabyte, 4 points, I think so. I mentioned about zettabytes a few minutes ago. So how many? 1 trillion gigabytes, 1 zettabyte. So data is going to grow from 100 zettabytes. That means 100 trillion gigabytes up. Understand? So when you talk about, we're looking at that amount of data in 2025. So you means we need more people to gain insight from this kind of information. So currently, we're looking at about 1.7 megabytes of new information will be created every second for every person. So imagine for every second, 1.7 MB. Tell me which device in the world can accommodate such data storage for every person for every second. We're looking at 1.7 MB. That means in a space of 24 hours, you filled every phone memory you have, every laptop memory you have for a particular person. So the point is, we're going to be diving into the world of IoT, a world of automated system, facial recognition. We need information like this. And in the world of security, everything needs information. Data is the key thing. So imagine for a single person. Can you hear me?
Yes, we can.
Mr. Lewis, can you hear me?
Yes, we can.
Okay, so imagine for a single person, yes. Okay, thank you. So imagine for a single person, we're storing about 1.7 megabytes of new information. So that's really scary. So that's one problem. The problem of the storing exponential growing huge data set. That's one problem. The second problem is processing data that have complex structure. Now, I pointed exactly that big data. When you talk about data, we have different types of data. We have the structured data, which is normal, your tabular form, quite easy to process. But when you talk about semi-structured data or structured data, so how do we process such data? So if someone gives you a log file to process, how do you process that? If someone gives you an XML file, how do you, or someone tells you go to my web page and extract information? That's really a complex issue. Or someone gives you an audio and tell you how do I process an audio message to get the kind of information I want. So that's another complex problem too, but it has solution, definitely. Now, knowing very well that we have large data set and we have different kind of structures for data. Now, processing data, having complex issues, just one problem. What about the speed at which you're going to process the data? Now, we haven't even solved the issue of processing data first. Now we're looking at the time, because if things cannot be done at real time, if things cannot be done in limited time within a time frame, we won't have, because the essence of data is for faster decision making. So if I can process data faster, so what's the essence of the information? So one is to process the data, two is to process the data in time. So these are problems with big data because it's actually big. If it was a small data set, fine, we can actually apply some simple tricks and we could do that. Basically, our traditional methods can help us. Basically, we have methods we've been using before. Now, how do we solve this problem? How do we solve this problem? For me, some people tell you that different ways you can solve the problem. You could actually go into cloud, you can do this, you can do that. But as a data scientist and machine learning person, I have realized that my path is really straight. It's quite strict with this stuff. So I tend to explain it with the tools I understand. Now, one technology that has caught my eye in recent years, in the past 5 years, yes, in the past 5 years, let's say 4 years, is what we call the Hadoop ecosystem. Now, basically, I know most of you must have heard about it. Now, the Hadoop ecosystem is a framework that basically allows you to store big data, process large data sets in parallel, and in a distributed fashion. So I'm going to explain what those means. When I say something is storing data and processing that data set in parallel and in distributed fashion, I'm going to explain what it means. So basically, why is Hadoop very important for me? Basically, now it is divided into two parts. One, we call the first part the HDFS, which we basically call the Hadoop distributed file system. So what does it do? It allows you to dump any kind of data across the cluster. So I'm going to explain what cluster means, so don't get confused with the big words. They're not really, they're just fancy words, but I'm going to explain. It's quite simple. So it simply allows you to dump any kind of data across the cluster. So imagine you're having a structured, a semi-structured, and unstructured data. Hadoop collects that kind of data, helps you dump that kind of information, which is beautiful. So now, it also has what we call a programming paradigm called MapReduce, which is used for processing. Now, it allows you process the data stored in the Hadoop distributed file system, which is called the HDFS. And that's beautiful. So you could save data, you can process it. So Hadoop gives you this key. So let me explain what that means. Before I go into Hadoop to explain the technology better, so I've mentioned parallel distributed fashion, I've mentioned cluster. So I need to give you insight what that means. So, but before I go into that, I'm going to just quickly talk about the evolution. Please, how many minutes do I have? So I won't talk more than time. Do I have up to 5 minutes?
Yes.
Okay, so I'm going to talk about the evolution of big data, so you could actually understand. So basically, in 2022, so I see 2022. In 2002, there was this guy called Doug Cutting. Doug is spelled Dough. Then Cutting is spelled Cutting, and another guy called Mike Caffarella. Now, both of them were data engineers. They were working on what they call Notch, Nutch. Now, quite an amazing project. Now, but in 2003, Google came up with this Google File Distributed System and MapReduce, which basically was somewhat an old version of what we have now. Now, in 2004, this Doug Cutting, him alone, adds this Google file system and MapReduce to Notch. Now, in 2006, Yahoo hired Doug Cutting, and that was how Hadoop was created. So basically, Hadoop was created as a Yahoo product. Now, in 2008, now there were applications around Hadoop starts to emerge. I'm going to explain all those applications. You must have heard about Apache Pig, Apache Spark, Hive, and the rest of that. But I'm going to, you've heard about Impala, I'm going to explain this stuff, but in a few minutes, let me see how far I can go. Now, in 2009, so we had new companies which was built on Hadoop started emerging. So in 2008, 2009 was a big deal for Hadoop. Now, basically asked me, if you go online and type Hadoop, what you see is an elephant. Now, basically, Hadoop is an elephant. How did the name come about? Now, Doug Cutting had has a son. The son has an elephant and a toy elephant, and the son usually calls the toy elephant Hadoop. So when the Okon was actually building the Hadoop project for Yahoo, he actually named the Hadoop named the project Hadoop, which basically makes sense because elephant big, so Hadoop an ecosystem for handling big data. So that practically makes sense. Now about Hadoop, we talked about Hadoop. Now basically Hadoop was built on Java, so it doesn't use much interface because it is Unix based. When I say something is Unix based, what do I mean? It really means we're looking at in terms of the operating system. So it simply means if you have a Linux computer, fine for you. If you have an Ubuntu computer, fine for you. If you have CentOS, that's excellent. So basically any Unix based system, if you have a Mac computer, good. So any Unix based system, that doesn't mean you can't use it on Windows. I think they have special interfaces now. I think Hadoop, you can find Hadoop for Windows now. But like I said, Hadoop initially was Unix based. Now the point here is I still prefer using my Kali Linux environment when dealing with Hadoop because it's much better for me. So now when I say it's built on Java, that doesn't mean it can be interpolated only with Java. Yeah, it allows you to use other programming languages like Scala and Python. Scala spelled SCELE and Python. So don't be scared if you don't like Java. That's not a problem. Now I mentioned earlier that Hadoop consists of two components, which is the HDFS, which is the Hadoop distributed file system, and the programming paradigm called MapReduce. So now let's understand this before I end. Now Hadoop which is divided into two. So let's look at the first one, which is the HDFS, which is the Hadoop distributed file system. So it is basically a distributed file system, which is used for storing files and directory. That's what it simply means. But it can optimize very large files in terms of terabytes and petabytes. So that's why it's different. So it's more like a cluster that could help you handle lots of amount of files. Now, files cannot be updated, beautiful. It's just a write once, read many kind of system. So it is fault tolerant. It simply means you don't have any backup. So what it simply means is the cluster is, I'm going to show you a diagram that explains that. When you make a copy of when you impute a particular file, make 3 copies of this file, so you don't need backup. So you have file saved across the name node or the subunit of the cluster, so you can always have your file anytime you want. Now, it runs on what we call commodity hardware. So that is simple English for telling you that your normal computer can actually handle it. So it does not need any storage platform to store the data. So it moves code to where data resides. So when I say it moves code to where data resides, it simply means that normally when we're dealing with data analysis, we have where we store information and we have what we call the business logic. Now, the business logic actually manipulates the information. Now, for the HDFS, now normally the data goes to where the code resides. But now the code goes to where the data resides when it comes to HDFS. So that's quite easy concept. Maybe when we have more time, I can explain. I'm trying to rush. Now, for the HDFS architecture, now it is what we call a master-slave architecture. Now, when I talk about that, it really means it's built as a cluster. So a cluster simply means a unit. So it has one master and other sub-units. So for one cluster. So we have one master per cluster. So the master manages the cluster or where the data is. He maintains metadata about the entire cluster. Also, he allocates work to other subunits in the cluster. So basically, those subunits is all called data node. So the data node itself is called the slave. Basically, takes up one node per cluster. So what does it really do? Basically, it allows for storage and read-write operation. So basically, that's all Hadoop does. That's all Hadoop does. I wish I had my slide. I would have showed you a diagram on how the architecture is. So you could actually go online and simply Google the Hadoop cluster and see how it looks like. So the most important thing when it comes to Hadoop here, we'll look at, we talked about the first problem, which is storing exponential data, growing data sets. So what solves that problem? HDFS. HDFS solves that problem. When you use Hadoop, how does Hadoop solve the problem? HDFS, because it's a distributed file system. So basically, it divides files into smaller units and stores it across the clusters. So no matter the amount of files you have, Hadoop can handle it. So basically, files are split up as data blocks. Those are stuff I need to show you physically if I have my way. So that's just one part of it, HDFS. So HDFS can handle the storing of exponential growth of data. And that's one of the problems we looked at when looking at big data. And the second thing we're going to look at here is storing of unstructured data. Now, HDFS also allows you to store any kind of data, structured or semi-structured or structured. The Hadoop distributed file system allows you to handle that kind of data. So now, the beautiful thing about this is it doesn't require any schema validation. So what that simply means is maybe you want to read a file, maybe on your Jupyter notebook. Let me say, assuming you want to read a file on your Jupyter. There's some files you can't just read. You have to install something for you to read those kind of files. So let me say, example, a scientific file, we call it LAS file, LAS file, .las file. You can't just up that file and read it. You have to download something, set your windows to this, to that, before you can actually read those kind of files. So Hadoop does not allow, it doesn't give you, there's no stress. There's no schema validation when you're talking about, okay, I want to read up a particular file, an unstructured file in Hadoop. So that's a beautiful thing. And this can be done using the Hadoop distributed file system. And that's how beautiful this stuff is. That's how beautiful it is. So now, the third problem we looked at here was the problem of processing data faster. Now, Hadoop uses what we call MapReduce to actually help us process this information faster. So I remember I told you about the cluster method, which is the master-slave method in the Hadoop ecosystem. Now, it allows you processing information parallel across the cluster, basically across the name node. I know that's a big word, but I think when you start studying Hadoop, you understand what this means. It allows you to process this information parallelly. That means one after the other, batch by batch. And this way, it allows you to process data locally. That means from each of the node, you can process this information, or the data you stored inside, and it allows you to process this information faster and smoother. Now, like I said earlier, MapReduce does this processing. And basically, it is a programming paradigm used to exploit the different nodes of HDFS, which is Hadoop distributed file system data. Now, that's basically it. So I'm going to go and summarize because I know my time is up. I would have talked about, I heard that the meetup is for 2 days, right? Is it for 2 days?
Yes, it is.
Yes. Okay, good. So fine.
Today
So
and
I'm going
tomorrow.
to quickly summarize. Yeah, so I won't actually waste your time with boring technical stuff. So I'm going to quick summarize. So when you talk about data, I'll tell you, data is basically life. With data is everything. Data is everything. I mentioned the careers in data science, big data analytics is the future. So one way or the other, every other tool will be dependent on data analytics. Every other tool, very soon, every app you'll be developing will be dependent on the data you're using, basically. Recently, I was working on a project, sentiment analysis using fuzzy logic for a doctor friend of mine. When I mean doctor, not a real doctor, I mean doctor kind of PhD kind of friend of mine. So basically, you could see how big organizations are paying AI engineers to formulate marketing strategy around data analysis, and it's beautiful. You get it's really beautiful. You see how we could actually stream real-time tweets and actually make sense of the information. You get, and it gives you idea on what to market, what to sell, what to buy, how to sell it, who to appease. So I think I wouldn't waste much time actually blabbing here. So I'm going to leave the floor open for the next speaker. Thank you very much. Thank you, Mr.
Thank
Lewis.
you very much, Dr. Vine.